Hello, in this video we're going to take a look at this last practice test question. This is kind of the harder one. This is one we've kind of turned the screws a little bit to make sure not only can you reproduce those kind of core algorithms we're talking about, but you can kind of think on your feet a bit and kind of deal with a little bit of kind of more challenging situation. So here we go. 14 is a lucky and humble number, so lucky it shares its luck. This function finds the total of all elements. I should have all elements that have 14 as a neighbor. The value 14 will never be included in the sum. So this is one of those situations where students will read this question and then they'll just say, I don't understand. And that's okay. It gets a little bit of a wordy problem. But what's really important here is at this point you stop and you take a look at some of the sample function calls, just to kind of see if you can kind of reverse engineer what the question is doing. Just so we know, this function takes a list as a parameter and it returns the sum of all values adjacent to a 14, not including any 14, just to be clear. So, lucky 14, here's my list. So I look at this, there's one 14 here, so the sum is going to be 1 plus 2, and there's another 14 there, plus 5 plus 2. So 1 plus 2 plus 5 plus 2 gives me 10. Okay, so you notice the thinking here is if I can find where the 14s are, I can just look one step behind it and one step in front of it, and then I can access those values. Now the second example has been picked very deliberately because this is where students typically will make a mistake on this one. And I say students, and really it's just anyone who's doing this might make a mistake on this point, is that because this 14 is in the very first index, so the index 0, or the first element, if we look to the left of that, we get an index out of bounds error. So you got to be careful, because if you inspect this element and then you try and look to the left of it, you're going to run into some problems with your code. So in this case, we find the 14, we can look to the right of it, and we see that there's a 2 there, and then there's no other 14, so the total is 2. This case has been picked very deliberately to demonstrate this situation where I have two 14s that are next to each other, and I have a 14 at the end. So this 14 at the end is very similar to the situation with the 14s at the front. That is, when I inspect this element, I can't look to the right of it because there's nothing there, and I get an index out of bounds error. Just a note, Python is really forgiving with index out of bounds, I find, with lists. Java is not. So if you're planning on writing the AP exam, which is a Java-based exam, you really want to kind of be thinking about, when you're doing these problems, watching for those index out of bounds errors, because even though Python is pretty forgiving in that sense, if you just kind of keep this in mind now, you're going to be really better off in the long run. So the other thing in this question is these two adjacent 14s. We want to make sure you don't add add one of them in there. So you see that the total you should get is 2 plus 1, which is 3, plus this 3 is 6. So, like I said, this is a more challenging question, and the challenge with this question is that you have to inspect the end elements. I'd say also and count for multiple 14s. Now, I don't know if this is the most efficient solution. I just kind of typed this up. If you have a more efficient solution, I'd love to hear it. But what I'm going to do is I'm going to set my sum, which is going to find my sum, keep track of my sum. I'm going to set that standard loop that's going to look at every element. And then what I need to do is I need to check if I is greater than 0. So basically, if I is greater than 0 and the element to the left of it is not a 14, I'm going to add the element to the left of it. Now, then I'm going to check if I is less than the length of the list minus 1, which is the last element, right? So it's the last index. Only then am I going to check to the right of it if it's not 14, which then I add to the sum. A really common mistake here that a student makes or someone who would make this an else if. But you have to remember these two conditions aren't exclusive to one another. You have to check them both, because you could have a situation where you have a list of length 1. And so it's just something to keep in mind. While I'm kind of talking, I think another good point here is What this question is getting at is can you access values by shifting off of the counter, which in this case is I. Right? That's a really important idea is can you have some sort of counter walking through a list and then shift off that appropriately. And so in an ideal world, I'll run this and it will work. And so I right click and I say run practice test. And we see we should get 10.26, and there's 10.26. So I hope this helped. Take a look. I would suggest, don't copy it down. Actually, if you take a look at this and then try and implement it on your own, and then try and change the question a little bit. Have a discussion with some of your peers of what might I do to make this question a little bit harder or a little bit different. And those are really good discussions, and you'll come up with some really interesting ideas that I'd love you to share with me. Anyways, have a wonderful day. And if you have any questions, please don't hesitate to ask. Have a great day.